Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about the construction of the isometric projections of the solid when the orthographic projections have been provided to us, right? So here we have a solid for which we have got the front view, we have got the top view, and we have also been provided with the left side view of the solid. Now these are three independent views which have been drawn onto the orthographic projections. Now we have to combine the information available through these orthographic projections into the 3D projection, which will be called isometric projection. And since into this isometric projection, since it is a 3D projection, so we are going to obtain the three faces of the solid in a single plane. So these three faces will be the front face, the top face, and the side face of the solid. So while we want to start with the isometric projections of the solid, so the first step we have to follow is that we need to evaluate the sizes of the front face, top face, and the side face of the solid. So let us first of all look at the projections which are available with us. So this is the front view. So please check the length of the solid. In the front view it is given to us 80 millimeter. Then in the front view we are also going to get the height. So the height of the solid is available to us from the side view, which is equal to 50 millimeter. So the front view rectangle shape will be going to be drawn corresponding to the size 80 millimeter by 50 millimeter. So this is the size of the front face rectangle. Similarly, the top face, in the top view we can check that the length of the solid will be same, that is equal to 80 millimeter, whereas the width of the solid has been provided to us 50 millimeter. So this rectangular surface which is going to contain the elements of the top view, this will be drawn for the size 80 millimeter by 50 millimeter. Now we move on to the side view. So in the side view we can check the width of this particular component is given to us. This is equal to 50 millimeter. So this is coming from the top view width over there. So this width which is observed in the top view will be same as the width obtained in the left side view. So this will be 50 millimeter, and the height of the solid also happens to be 50 millimeter. So the side face will be the square which will be of the size 50 millimeter by 50 millimeter. Now let us see in which orientations we have to draw all these faces over there. So here we have the isometric construction or the isometric axis. So this is our x-axis, this is our z-axis, and this is our y-axis. And now as we can look at these orthographic projections, we have been provided with the left side view of the solid which has been constructed on the right side of the front view. So since we are going to look at the solid from the left hand side, so this is the left side view which will be observed. It means that our side view should be drawn in such a way that we should be viewing the side view from the left hand side. So that is why the side face of this particular cuboid which we are going to draw over here, it will be drawn on the left hand side, so that on the x and y plane, that is this is the x dimension, this is the y axis over here. So x-axis and y-axis is going to contain the side face. So my side face will be like this. And what is the size of the side face? The size of the side face happens to be 50 millimeter by 50 millimeter. So the h which will be drawn along the x-axis, this will be 50 millimeter. This will be representing the width of the solid. Whereas this h which is going to represent the height of the solid along the y-axis, this will complete the two edges of the square, and correspondingly two more isometric lines, they will be drawn parallel to this edge, and another one edge will be drawn parallel to the width edge over here. Now this is our side face. Now if this is the side face, so our front face will be lying in this orientation. So what are the dimensions of the front face? The front face dimensions, they happen to be 80 millimeter by 50 millimeter. So 50 millimeter height we have already obtained from the side view. So this is the length of the solid, which happens to be equal to 80 millimeter. So this is the 80 millimeter edge length corresponding to the solid front view. So this has been plotted over here. Now we have to plot the top view. In order to plot the top view, we know the dimensions 80 by 50. So 80 is the length. So this length we have already plotted, 80 millimeter. Then the width of the solid, it is 50. It is given over here, 50 millimeter. So 80 by 50. So this is 50. This is 80. So 80 by 50. So again, one more, you see, isometric line I will be drawing corresponding to the base parallel to the z-axis. Similarly, another isometric line parallel to the x-axis will be drawn. So this is going to complete our base, and this is going to give us the top view, because the top face will be also same as your base of this particular cuboid. So this way we know the orientation. Here along the x-axis I am going to draw the edge for 50. Along the y-axis the edge will be equal to 50, and along the z-axis the edge will be drawn equal to 80 millimeter. And now whatever dimensions are there mentioned onto this particular object in the three orthographic views, all these dimensions must be converted into the isometric lens. Only then we can start with the construction of the isometric projections. And then let us start with working out these projections. And while we have to start with working out the projections, so first thing was you convert all these dimensions from the true shape onto the isometric length. That is first thing. Second, we can start with the isometric projections only when we are able to develop proper understanding about the different segments of this particular construction over there. So this is the view of any given product that we have got: front view, top view, and the left side view. Now what we need to do, if we start looking at this construction, that is front, top and side view straight away, it may be little bit confusing or misleading. So what we have to do, we have to start with, first of all, dividing this total construction into smaller elements, because once we are able to divide this construction into the smaller elements, so we will be able to project those elements into the isometric projections with relative ease. So let us see how we can divide this overall component into the smaller elements over there. Now please check, I can divide this total object into two elements. Please check. The first element is, this is a lower block, that is the lower portion of this particular construction. It is this one. So you can check, if I am looking from this side, so the complete edge, that is this rectangle, I will be able to see. This is the height of the rectangle, this is the width of the rectangle. So this I am able to observe in the side view. So in the side view I am able to observe this size. What is this? This is equal to 50 millimeter and this is equal to 20 millimeter. So total height happens to be 50, out of which the lower block, it is equal to height 20 millimeter. So that this remaining portion, it is going to have the height is equal to 30 millimeter, right? So total is 50, 20 millimeter is given over here, that is the height of the base block. You can say this is the basic block or the lower block over here. So lower block is having the length, please check, it is going to have the length equal to 80 millimeter. It is going to have the width which is equal to 50 millimeter, and it is going to have the height which is equal to 20 millimeter. So this lower part, that is element number 1, I have evaluated. So once I evaluate or draw this particular block onto the isometric projection, half of the construction would be completed. Then in the second part, please check, my second element is this one, because over here if I look, I am able to get two segments over there. One segment is for 30 millimeter length and then it is 20 millimeter length. It means that there is this segment over here. Please check. this is a segment which is having the shape of a 7. So this is a 7 shaped segment over here. You see, this is a projected portion and this is basically shaping like a 7. Now, if I look at this element number 2, what do I observe? Number 1, this element which is shaped equal to 7, it is a single element. From the top view, I observe that it is a single element over there. Second thing, I know the shape of this segment, that is element 2 from the top view. Then from the front view, what information do I get? The height of this segment is equal to 30 millimeter. Please check. Height of this element, it is equal to 30 millimeter. And third information is available to me about this segment from the side view. If I look at this segment from the side view, please check. I am looking at this from this side. If I am looking from this side, you see there is one rectangle which I am getting corresponding to this edge, this vertical edge, which is equal to 25 by 30 millimeter. This is 25, this is 30. And the second segment, you see, this segment I am able to view from the side view. So this is also having the size 25, because if this is 25, total is 50. So total is 50. If this is 25, this is also 25. It means both of these rectangular segments, they are of equal shape. Only thing is, this segment is lying little bit ahead, whereas this segment, it is lying at a distance of 30 millimeter from this right corner edge over here. This is the right corner edge. From the right corner edge, if I move 30 millimeter forward, I will be getting first rectangle, which is this one. If I move 20 millimeter further towards the left corner, then again 25 millimeter will give me 25 by 30 millimeter will give me this shape of this particular rectangle. So this rectangle, please check, it is lying ahead. It is at a distance of 50 millimeter from the right corner. This is my right corner. From the right corner, this distance will be 50. Why? Because this is 20 and this is 30 over here. So 20 plus 30 gives me 50. So this 30 is available over here. So this 30 I have transferred here so that I can have the total edge length of this vertical edge from the right corner, right? So I am working it out this way, that this element will be starting 50 millimeter from the right corner, move 25 millimeter parallel to this edge, and then move 20 millimeter back, again have 25 millimeter width corresponding to this edge over here. So corresponding to this total width, 25 millimeter will be corresponding to this segment, 25 millimeter width will be corresponding to this segment. Depth of both of these segments will be how much? It is equal to 30 millimeter. So this way I have decoded element number 1, which was this segment over here, this segment over here, and I have decoded the second element, which was this segment, upper portion of this segment. So the upper element is having the shape of a 7 over here. Okay, so this is the shape. So this also I have decoded, that from right corner you move 50 millimeter forward, have edge equal to 25 millimeter parallel to this edge or parallel to this edge. Then you move 20 millimeter backward, and again for parallel to the width over here, again 25 millimeter you have to move from this corner to this corner. So this way we are going to construct this particular solid onto the isometric projection. So let us start. So we have drawn a horizontal datum line. So this is our horizontal datum line. From the horizontal datum line, we are going to mark a point of origin. From this point of origin towards the left 30 degree, we have drawn the isometric x-axis over here. This isometric axis has been drawn at an angle of 30 degree. Then from the same point, you move towards the right, and this isometric z-axis has been drawn at an angle of 30 degree. Then the height of this solid will be represented along the y-axis, which will be perpendicular to this datum line. Now let us start with the side face, because we have to draw the left side face over here. So size is 50 millimeter height and 50 millimeter is the width over here. Please check. This is the 50 millimeter width. This is the 50 millimeter height. So this is a square of 50 by 50. The left side view we have already discussed. It is 50 by 50. So 50 millimeter length I have marked on the x-axis, right? Then I draw the vertical edge equal to 50 millimeter over here. So this is also 50 millimeter. This is the y-axis. So this is my isometric length corresponding to one of the edge of this square. Similarly, one more edge of the square I am going to draw over here. So this edge equal to 50 millimeter is parallel to the x-axis. This edge of the square, which corresponds to the side face of this solid, so this is 50 millimeter and this is parallel to the y-axis. So this is the height of the solid. Please check. Along y-axis we have marked the height, and along x-axis we have marked the width of the solid. So this is the face which corresponds to the left side view. So we have marked left side view over here. Now if this face is left side view, then this face will be the another view, which is the front view. So in the front view, what are the dimensions? 80 millimeter happens to be the length, 50 millimeter happens to be the height. So this height is coming from the side view. So side view is 50 millimeter. So this height is 50 millimeter, length is 80. So now height 50 we have already drawn through the side view. This is 50 millimeter. Now we have to draw length is equal to 80 millimeter over here. So this length of 80 millimeter will be marked along the z-axis. So please see, this is our z-axis. So along the z-axis we have marked the length of this solid. And again, in order to complete this rectangular shape corresponding to the front face, so I have to draw two isometric line. One vertical isometric line which will be parallel to the y-axis, and this will be having the edge length is equal to 50 millimeter. Another, you see, line, isometric line I have to draw which will be parallel to the z-axis, and it will be measuring 80 millimeter. So this is my front view face over here. So the front view face has been obtained, side view face has been obtained. Now let us obtain the top view face. So top view will be, you draw another isometric edge over here, 80 millimeter parallel to this and parallel to the z-axis. Draw another isometric edge which will be measuring 50 millimeter parallel to this edge and parallel to the x-axis over here, right? So this is my top face. So the top face dimension we already know, it is 80 by 50. So this is 80 millimeter length, this is 50 millimeter length. Now let us draw the bottom face over here. In order to draw the bottom face, please check. Another edge from this point will be drawn 80 millimeter length up to this, and this will be parallel to the z-axis. And then we have to draw another isometric edge which will be parallel to the x-axis, and this will be measuring 50 millimeter. So since this side is a square, so these two edges they are going to merge over here. Then we have to draw one vertical edge over here corresponding to the rear face of the square prism. So this is a square prism, you see, which we have obtained, right? So this is the vertical edge corresponding to the rear point of this particular back face over here. Now this is a square prism. How we have obtained a square prism? Because the height of the solid and the width of the solid remains the same. So had these values been different, then we would have obtained a rectangular prism over here. So this has been become a case of square prism. Now side face is located, front face is located, top face is located. Now we have to draw the element number 1. So please check. The element number 1 is having the dimensions 20 millimeter height, 80 millimeter is the length, and the width is how much? Width is equal to 50 millimeter. You can check. Element number 1, width is equal to 50 millimeter, length it is equal to 80 millimeter, and height it is equal to 20 millimeter. So please check. This is the width 50, length 80. Now I need to draw the height. So corresponding to height 20, I am going to draw a ring over here. Just like the earlier cases, I have drawn a ring. That is, this is a height of 20 millimeter. So along all the four sides of this square prism, we have drawn isometric lines which are parallel to x-axis and which are parallel to z axis over here. So please see, these two edges, they are parallel to z axis, and these two edges, they are parallel to x axis, and obviously the vertical lengths, they are parallel to the y axis. So this is the height 20. So please check this height 20. So element number 1 has been drawn over here. Element number 1, it has been drawn. That is, you have the width 50, length you have got as 80 millimeter, height we have got equal to 20 millimeter. Now let us work out how this 7 shape structure, this is the element number 2, right? So this is a 7 shape structure which has been mounted above this particular face. Please check, this is the top face of the lower element. So onto the top face of the lower element, we are going to mount this particular structure over there. So this is a structure which is having the dimensions. Please check, from this corner. So which one is this corner? This corner is this one, right? This corner, it is equivalent to this corner. So from this corner we will be measuring 50 mm towards the first corner. So from this corner we will be measuring 50 millimeter, or else you measure 30 millimeter from here. So this will automatically be 50 millimeter. And then once you reach this point, then what is to be done? 25 millimeter you have to move forward parallel to either this edge or parallel to this edge. So from this point 50 millimeter, I will be moving 25 millimeter parallel to this axis, that is the x axis, or this particular isometric length which is parallel to x axis. Now once I move 25 millimeter over here, so this point will be located, and then I will be moving 20 millimeter back, and then I will be reaching by moving 25 millimeter along this edge, so that this distance becomes my 30 millimeter. So please see, this is 30, this distance will be 25, this distance will be 20, and this distance over here, this will be 50. So this 7 can be constructed on the top face. So let us start working upon the element number 2. So please see, I have marked this particular edge equal to 50 millimeter. So this is the point, right? So how I have obtained this? Either you can leave 30 from this side as we have discussed, or you can mark 50 millimeter from this corner over here. So this, any dimensions which I am showing it onto the isometric projection marked with this lighter color, so these are only required for the purpose of guidance. Whereas if this is 80, this is 50, so this is automatic, this is 30, this will automatically be equal to 50 millimeter, right? So you can omit these dimensions, but still I want to show it to you because that will give you better clarity for the purpose of understanding, right? Otherwise these are the redundant dimensions. So all dimensions shown on this isometric projection construction with this color, these are all supplementary dimensions or the redundant dimension which could be omitted otherwise. Now I have moved from this corner, distance is equal to 50 millimeter. So from this point I know the depth. How much is the depth of this particular second element? This is equal to 30 millimeter. So please check, the depth of this element is equal to 30, and where from it will start? It will start from a point 50 millimeter as you move from this point to this point. So from this point we are moving 50 millimeter towards this end. Now we have to move 30 millimeter down. So as we move 30 millimeter down, so automatically you see the total dimension was 50, the ring dimension height was 20, so this is automatically 30. But still, for the purpose of clarity, this 30 I have shown again with a orange color, lighter color I have shown it over there, right? So this is a lighter color, means you can omit these dimensions, but still I have shown it 30 millimeter I am coming down. Now once I reach this point, and this point has been obtained, now from this point I need to move 25 millimeter parallel to this one. Please see, either this edge or parallel to this edge, that is x axis. So from here, please check, I have moved 25 millimeter, that is midpoint of this length. So this total length was 50. So I have moved towards this edge by a distance of 25 millimeter. So please check, I have shown this is blue measurement, it means it would be required. This is the mandatory or the necessary measurement. So I have moved 25 millimeter from this corner towards this corner. So this point would be the midpoint of this total width of the solid. Please check. This is the total width of the solid 50. So I have moved 25 millimeter from this corner to this corner. So from this corner to this corner or from this corner to this corner, I have moved 25 millimeter. Now I will be drawing a vertical line which will be showing me this particular edge over here. This is the edge. This edge will be visible once I draw this vertical line. It means I have been able to show this vertical face, and where this vertical face is available, this is available in the side view. Please check. This is available in the side view where the width is 30 and the height of this rectangular face, this happens to be 30 millimeter. So height is 30. Please check. The height of this rectangular surface, it is 30. Width of this rectangular surface happens to be 25. Now from this point I need to work out 20 millimeter backwards from this point towards this point. So from here I will be moving 20 millimeter now backward towards this edge over here, rear edge, right? So from this point, please see, I will be moving backward. If I have to move backward, so this isometric line will be parallel to this edge or the z axis. So please check, this 20 millimeter distance I have drawn along the isometric line which is parallel to the z axis. So I am moving towards this, please check, rear edge, and I am moving parallel to the z axis over here. So 20 millimeter back. So let me show this dimension. Check it out. 20 millimeter from this face I am moving backward. Again, this is a blue dimension. It is mandatory dimension, must be shown, right? So it is not something which is for explanation. So for 20 millimeter I am moving back. Please check, from here to this point, from here to this point, where this is visible, where this total rectangle is visible, this rectangular shape is visible. Please check in the front view. This rectangular face, let us look at the dimensions of this face. Dimensions of this face, they are 20 millimeter is the width, 30 millimeter is the height. Please check, 20 millimeter is the width, 30 millimeter is the height. Now I have reached this point. Which is this point? It is this point. Now from this point, now I will be moving 25 millimeter towards the front edge over there. This is the front edge of the solid. So from here, parallel to this edge, please check, x-axis parallel to this edge or parallel to this edge, I will be moving from this point to the front edge of this solid. So please check, from this particular corner or this particular corner, I am moving to the front edge. This is my front edge of the solid. This is my front edge of the solid. And how much is this distance? This distance is again equal to 25 millimeter. This distance, it is again equal to 25. And then I will be joining this vertical edge so that my rectangular face is completed. So this is the completion of my rectangular face. Now let me see where this rectangular face is visible. Once again, this face was available in the side view. This face will also be available in the side view. So this is first face, which is this one. This is my second rectangular face. Dimensions of both these faces, they are same. 25 by 30. 25 is the width, 30 is the height over here. 25 is the width, 30 is the height. So 25 is the width, 30 is the height. 25 is the width, 30 is the height. So with this, you can check this 7 shape construction has been completed in the top view. These two faces, they have been completed in the side view, in the front view. This rectangular face we have obtained, and then this is the longer rectangle we can get. This is again shape of an L. Please check, this is the shape of an L over here. So it means that this surface is going to be continuous. So over here, I am going to join this L shape over here, right? So I am not going to join this part. So let me join the dark portion. So the projections, they have already been developed. Only thing is, now we are going to highlight the edges of the isometric projections of this solid. So please check, this is my top face which corresponds to this line. This is my top face. Then I will be highlighting this portion, right? This is the 7 shape which was there. So this will be highlighted. So this is the vertical face which I have highlighted over here. Then it is this one side, that is this face I have highlighted, this face over here. So this face was highlighted as it is shown over here. This face has been highlighted and it has been shown over here. Then this face, second face, will be highlighted as it appears to be in the side view. So the two faces in the side view, they have been shown over here. One face which was available in the front view, it has been shown over here. Then this is the L shape. Please check. This is the L shape. Again, we can show it over here. Now where does it appear? This L appears in the front view. Please see. This L appears to us, it is visible to us in the front view. And this face, this is visible to us in the side view. Please check, this face will be this one. Okay, so this face is visible to us in the side view. So we are left with only one line over here, that is corresponding to the top view. So this line, this edge, we are required to join over here. So this completes the construction of the isometric projections of the solid. Once the information regarding the orthographic projections, they were available to us, and the construction, we have seen that you can simplify this construction when you can divide this solid into multiple elements over here, so that we are going to draw the construction of each element one by one. You cannot start with the overall construction of the solid straight away into the isometric projection. So divide the solid into multiple elements, start with the basic construction of the bottom element, and then keep on building the other elements on the top of the basic building block. So this way, this is the procedure for evaluating the isometric projections of the solid when the orthographic projections of the solid, they are available. So I hope with this discussion you would have known about how do we proceed regarding the construction of the isometric projections from the orthographic projection. So this is all for today. So we will be continuing with further discussions regarding few more cases on the isometric projections in the coming lectures. Thank you very much. Thanks a lot.